Imagine a world where your sky is electric blue at noon and deep violet at night, and your sun is a roaring blue giant that could fry Earth in minutes. Stay with me, because by the end, you'll know if life could really survive there. Here's the deal. Blue giant stars are cosmic monsters, hot, bright, short-lived. In this video, we'll explore what they are, how they shape their planets, and whether any kind of life could exist in their deadly glow. First, what is a blue giant? Think of a star many times heavier than our sun, burning fuel insanely fast. It shines a fierce blue-white, blasting intense radiation in all directions, like a cosmic blowtorch in deep space. Because they burn fuel so fast, blue giants live quickly and die young, often just a few million years. Compared to our sun's billions of years, that's like a hyperactive sprinter collapsing after a single lap. Now imagine a rocky planet orbiting close enough to feel warm but not vaporized. It needs to be far from the raging surface, yet still inside a narrow habitable zone, where liquid water could survive for at least a while. Here's the catch. This habitable zone is far away, and the star is wildly bright. That means long years, extreme radiation, and powerful stellar winds. Any life here would need clever ways to hide, shield, or adapt to survive. Picture standing on that planet. Well, if you could, the blue star would fill much of the sky, shining a harsh turquoise light. Shadows would look strange, colors shifted, and days could feel intensely bright, almost alien. Life here might hide underwater. Thick oceans could block deadly radiation, turning the upper layers into a glowing blue-green world where strange, simple organisms drift and feed on the star's intense energy. In such oceans, photosynthetic life would need strong pigments to handle fierce ultraviolet light. Imagine algae-like mats in deep teal and violet, turning dangerous energy into food, painting the seafloor with weird colors. But what about land? The surface would be harsh. Constant particle storms, intense ultraviolet, maybe flares. Any land life might stay underground in caves or tunnels, using rock as a shield while feeding on chemical energy. Even the atmosphere would be different. Strong radiation could strip gases away unless the planet has powerful gravity and a strong magnetic field. Thick, hazy skies might scatter the blue light into eerie shades of violet. Here's a twist. Blue giants change fast. Their brightness and temperature can shift over time, moving the habitable zone. A planet comfortable for a while might suddenly become frozen or scorched as the star evolves. So could complex life ever appear? Evolution needs time. On Earth, it took billions of years to go from microbes to animals. Around a blue giant, the clock ticks much faster, giving only a tiny window for complexity to grow. Maybe the best candidates are simple, robust organisms, microbes in oceans, under ice, or buried deep in rock. They could adapt quickly, trading complexity for speed, thriving in niches we'd find incredibly hostile. And when the blue giant nears its end, things get wild. It swells, brightens, and sheds material into space. Any nearby planets are blasted by huge storms of gas and radiation, a final test for whatever life remains. Eventually, the star may explode as a supernova, releasing more energy in seconds than our sun will in its lifetime. For any life forms, this is game over, but also a beginning for new stars and planets formed from the debris. The elements in your body, carbon, oxygen, iron, are forged in stars like these. So even if life can't last long around a blue giant, such stars may still be essential for life to exist anywhere in the universe at all. Now, what would day and night feel like there? The long orbit might make seasons extreme. One side of the planet could bake in fierce light, while the other spends ages in dim violet twilight, with life clinging to the edges. Maybe life prefers the twilight zones, not too bright, not too dark. Imagine belts of strange forests or algae fields circling the planet, always living on the boundary between deadly day and freezing night. Communication between such life forms, if intelligent, might rely less on long histories and more on rapid change. Civilizations would know their star is short-lived, pushing them to act fast, explore fast, adapt fast. Could we ever detect them? We'd look for unusual atmospheres, maybe odd mixes of gases that don't fit simple chemistry. Even brief bursts of life could leave faint signatures in a planet's air, like fingerprints in starlight. Telescopes on Earth already study blue stars and their surroundings. They see disks of gas, newborn planets, and powerful winds. Each observation teaches us how extreme, short-lived systems might still host pockets of habitability. In science fiction, blue giants often mean danger, doomed worlds and dramatic skies. Reality is more subtle, dangerous, yes, but also creative, seeding space with heavy elements and maybe brief sparks of alien biology. So could you ever vacation there? Not safely. Radiation and unstable orbits would make it lethal for humans. But robotic probes and distant telescopes could watch from afar, turning these extreme systems into cosmic laboratories. The real question isn't just, is life possible, but how weird could it be? Blue giant systems force us to stretch our imaginations. Deep oceans, underground biospheres, quick evolution, and civilizations racing against time. And that brings us back to you. When you look at a bright blue star in the night sky, you might be seeing a short, furious chapter in the universe's story. A chapter where life, if it exists, must think and act very quickly. By now, you've seen how hostile, fast, and fascinating life around a blue giant would be. In a moment, I'll tell you what this reveals about our own fragile place around a calmer star, and why that matters for our future. Our sun may seem ordinary, but its long, stable life is exactly what allowed complex life and civilizations to emerge here. Studying blue giants reminds us how lucky we are to orbit a quieter, patient star. If this journey around a blue giant sparked new questions in your mind, that's perfect. The universe is full of extreme places, and each one might rewrite what we think habitable really means. Ready to explore the next one?